The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Making Single Digit Adjustments in the Decimal Parts. In the decimal numbers, the decimal portion may have 1 digit, 2 digits, 3 digits and more. If the number of digits in the decimal part is 3 or less, the addition process is easy, as we can simply treat that as whole numbers and perform addition, and the separating dot on the abacus will automatically distinguish the whole number and the decimal part. Though decimal additions in the school level may not involve too many digits, in teaching abacus we have to deal with all types of scenarios and suggest how decimal problems with higher digits of decimal portions can be handled. One option already suggested is that we take the second separating dot from the right, indicating the decimal portions in case the digits are more than 3. Yet another method is to make adjustments in the decimal part of the number itself to make it to 3 digits and carry out the corrective measures in the result. Let us see how this can be done using the example 42.3527 plus 26.4239. The adjustment technique involves converting the last digit of the decimal portion into its higher digit value. Here 352 are the first 3 digits of the decimal portion and 7 is the last one. We can convert the 7 into multiples of 10 and add it with the digit 2 of the decimal portion. That is, 2 can be increased by 1, thus making the 4-digit number as 353. The meaning is that we have added 3 to the 7 to make it 10, which means the one with existing 352 makes the number 353 and the last digit as 0. Likewise, let us take the second decimal number, in which case the decimal portion is 4239. Let us convert this into 3 digits. That means it becomes 424, indicating that we have added 1 to the last digit 9, thus making the last digit as 0. The adjustment indicates that we have added 1 to the second number to convert it to a 3-digit decimal part. Technically speaking, the 4th digit of the number becomes 0. The meaning here is that we have added 3 to the first number and 1 to the second number, and therefore the total 4 should be subtracted from the final result by treating the decimal portion having 4 digits with the last digit as 0. With this process, we have converted the two numbers as 42.353 and 26.424. Let us consider this as whole numbers and set it from the right extreme of the abacus. That is 4 in the units column, 2 in the tens column, 4 in the hundreds column 6 in the thousands column and 2 in the 10,000s column. Let us set the second number at the extreme left of the abacus. That is 4, 2, 3, 5, 3. Let us add 4 with 2. That becomes 6. Let us add 2 with 6 and that becomes 8. Let us add 3 with 4 in the hundreds column. That makes it 7. That is, add 5 in the upper abacus and clear 2 in the lower abacus. Let us add 5 in the tens column, and finally we have to add 3 in the units column. That is, add 5 in the upper abacus and subtract 2 in the lower abacus. We get the result as 6, 8, 7, 7, 7. We can notice that the dot on the separating bar is distinguishing the whole number and the decimal part. If you reconvert the result into a decimal number, the result we get is 68.777. As we converted the 4-digit decimal part into 3-digit by making the last digit as 0, we have to take the number as 68.7770 for making the final adjustment. We already mentioned that in making the adjustment, we added 3 to the first decimal number and 1 to the second number. That means we have added 4 in the conversion process that should be subtracted from the final decimal portion of the result, which makes the number as 68.7766. As subtracting 4 from 70 gives 66 as the last 2 digits. Hope this adjustment process is less complicated compared to other methods, as it involves the normal addition process and at the same time the separating dot naturally classifies the whole number and decimal part in the result. Let us take up problems where double-digit adjustment may be necessary in arriving at the final result.